As the 19th century drew to a close, Newton's classical mechanics and Maxwell's electromagnetic theory seemed to be the twin foundations of an edifice of physics that would stand forever. But it was a forever that was destined not to last very long. What could have been missing? It certainly didn't seem like much at the time. Just a few little details that didn't quite fit the big picture. For example, Albert A. Michelson had built a wonderful device to measure the motion of the Earth by studying shifting fringes of light. Just a small shift in the pattern, that was all that could be expected. But when Michelson twisted his interferometer in the ether wind, instead of the small shift he expected, there was none at all. Then there was the curious case of Max Planck. His problem was explaining the color of a hot, glowing body. And to solve his problem, he needed to introduce a new constant. It was a very, very small constant. In fact, Planck hoped it would vanish entirely. But it did not vanish. And then there was the strange story of Ernest Rutherford. When he bombarded a thin cold foil with natural alpha rays, the experiment worked almost perfectly.
Nuclear chemistry.
Nearly all the alpha rays sliced right through the foil, just as they were supposed to. Only a very few bounced back. But how could it be that any bounced back at all? From these modest beginnings, the new revolution arose, and no one played a more powerful role than young Albert Einstein. In the world of physics, the year 1905 in the life of young Mr. Einstein, he would submit his doctoral thesis in that very year, would be remembered on a par with the year 1665. That was the year that young Isaac Newton fled to rural Lincolnshire to escape the plague in London, and completed perhaps his most important work. But unlike Newton, who used his peaceful respite to find the answers to the revolutionary questions of the past, Albert Einstein, in 1905, made discoveries that really got the new revolution going. The problem of Michelson's interferometer could be solved, as Hendrik Lorentz had shown, if different observers measure different times and distances. But Albert Einstein went further, combining space and time into a seamless continuum. And Einstein's 1905 special theory of relativity was only the first step, not the last.